Hello, hello. Nice hoodie you got there.
Yeah, no, look at you, Mr. Fancy. What's funny is this is the difference in lighting. My hoodie is the exact same color as your hoodie. It just looks blue with the light bouncing on me.
Just way blue. That's
Yep.
funny. Yeah.
Well, thanks for joining us, everybody. I see that people already rolling in. Today should be pretty interesting with what we're going to talk about. We're going into hygiene. So, with that in mind, quick question for you, Tyler. Have you properly dusted and Lysoled your computer lately? Is it clean?
Uh,
Is it good?
yeah, I did right before we went on our trip last week. It had a lot of dust on it from just sitting here at my desk for the last year.
At least you're keeping up with it. Hey, what's going on, Josh? What's going on, Sean? Thanks for joining us, everybody. So we'll give it just a second. So yeah, hygiene. We have been doing a real deep dive lately because we think it's a really important topic, but it's also something a lot of our customers are looking to see surrounding cyber hygiene and the overall, I guess you could say, health of their endpoints, their environments, things like that. So we wanted to show off to you guys a couple threats we've had in the threat catalog for a few months now to kind of kickstart this whole cyber hygiene process. It's going to expand into a lot more here at Scythe into different capabilities and feature sets for the platform as a whole. But everything has to start somewhere, right? So if most of you don't know, me and Tyler have got a pretty long background working together and being in the Marine Corps together and just doing general cyber stuff in a bunch of different fields and niches and markets and verticals. And one of the things we had noticed is everyone has a different standard, different format, things to follow, the way they maintain their gold images, they validate drift, stuff like that. And everyone's got different compliance mechanisms they have to meet. For us, what we were in, it was STIGs, and it was super easy. Do the thing. If you didn't do the thing, you're wrong. So we decided to start creating our own little, I guess let's call it a beta or a first implementation of cyber hygiene threats. And what these are going to do is kind of hop in there and do a quick run and give you a quick output in return of the status of your endpoints, where it looks when it comes to the most critical, say, benchmarks or checks, and ways you can fix them. So with that, let me go ahead and throw this up here on the screen so you guys can just kind of get a feel for what we've got here. We built this one. I'm showing obviously the page for Windows, but we built these for Windows, macOS, and Linux. And they do a quick run, basically downloads some scripts, runs a bunch of checks against the endpoint for you, and then feeds you back a result, kind of like what you can see here on the screen. And they're really, I don't really know how to explain it, but it's simplistic but complex at the same time. We try to make it as easy as possible for you guys to run these threats and also get a return that's usable and gives you an idea of what you need to do to improve that baseline. So with that, Tyler, let's talk to them a bit about the controls and STIGs in general and what's going on there.
Yeah, sure. So like Trey said, we um these are all based off of the DISA-STIG controls. So they are essentially, like you said, just to create a like a secure baseline, a secure baseline image to get you started, make sure that you're hitting kind of all of these not low hanging fruit, but these critical controls that are often overlooked. So inside of the STIGs, there are several different categories: Cat 1s, 2s, and 3s. We focused here initially in this on this alpha deployment of it. Almost, we focused on category 1, which are the critical controls. So they classify the critical controls as a vulnerability that, if exploited, would compromise the CIA triad, the confidentiality, integrity, or availability of your information systems. And in as far as like the government is concerned, you have to employ these STIGs on your endpoints before they're allowed to connect to the network or perform any other or before they can connect to the network, or you're able to run them in your production environment. But these STIGs apply across more than just government assets. They're just a great way to, like I said, get a kickstart, like a secure baseline almost into or onto your endpoints before you focus on more complicated or more complex security or detections. So these are So they are STIGs, which is the government, but it's also they're cross-referenced with the NIST framework and the CIS CIS benchmarks. So they apply over more than just the government vertical. They really apply to all endpoints, and it really means for good security for everybody.
And that was a big reason why we picked these, was they did have that overlap with 853 and the sys controls, and it brought it all into like one central point. So you're not trying to do crazy mappings. If you dive deeper into the STIGs themselves and the ones we reference here, they actually walk you through where it's connected to all of the other frameworks, which is really helpful when you're trying to do these things and follow compliance from 5 or 10 different organizations.
Yeah, for sure. So in the actual threat or the campaign itself, we have all of them tagged in there. So when you run the threat, you're able to reference the other, like I said, the NIST or CIS, the CIS benchmarks, to be able to reference those in their documentation, as well as in the output, we reference what the STIG unique ID is. So you can look that up if you need some more context on what it's actually running and why it's important. But what?
I was just showing the ID in there in the page. That was all. You're good.
Oh, okay. Oh, I was like, what are you looking at? But we had some of the key checks that it goes to look in. So in Windows, it checks. I think it runs. I think each of these run 15 to 17 Category 1, and what we deem as important or critical Category 2s. So I think it runs, like I said, between 15 to 17 checks. Some of the main ones in Windows that it looks at are some WinRM authentication levels. So WinRM is the process that's utilized to perform PowerShell remoting across your enterprise. So you want to make sure that the level is above basic, that the credentials are stored in a secure fashion. I think we showed a few weeks ago how you're actually able to pull out the credential variable from inside of your machine. So you don't want to be able to do that. And that really aids in limiting of credential harvesting as well as lateral movement across your environment. Servers, Windows servers are built in to automatically run and accept PowerShell remoting requests, and connections are kind of built like that by design. So ensuring that you have solid controls over those is really important, because if you can essentially live off the land, utilize PowerShell to remote across the network, and to domain controllers or other servers, Exchange servers, file servers, things like that, kind of not automatically, but they come with it pre-installed. It's a feature, not a bug.
Yep.
So
And we saw that big effect in the PSWA stuff
yep.
we were talking about just a few weeks ago too.
Yeah, for sure. So it checks for that. It also, and this next one applies to all three operating systems. So it checks to make sure that you have disabled any outdated or vulnerable protocols or services. So for Windows, that applies to older versions or unsecure versions of SMB, which again is how your domain controller and your Windows machines talk to each other. You want to make sure that that's secure, and it's another form of lateral movement. Landman, which is an old, probably older than Trey, and man, that's old, but an old authentication protocol that had very, very weak passwords. And actually, I think it was from Windows Vista that would only allow you to set up to 15 character passwords. So not a great policy, but it's still around, which is why it's important that even though some of these checks might seem a little outdated or maybe even kind of silly or simple, these things still exist or are still exploited, right? And then another one that was kind of new to me, I've never seen this before, but it has you disable the solicited remote assistance, which is a service, a feature, if you will, inside of Windows, where an external party can request access to your endpoint, and then they'll have a remote session to your device that you've allowed with your permissions. So just going in and disabling that, which is a new one for me. I had never heard of that before. And then the last one I wanted to hit on for Windows was that one of the checks also goes in and restricts anonymous access to named pipes. So named pipes, if you're familiar, is a big thing in Cobalt Strike for performing lateral movement. It essentially stands up a named pipe on a machine. You're able to connect to it that way. And I think it goes over SMB or the NetBIOS protocol, to allow for lateral movement. Again, living off the land, utilizing things that come as a feature in in Windows and just going in and restricting things like that. Make this low hanging fruit a little bit harder for adversaries to exploit, right?
Mhm.
And then over to macOS, some of the key ones in that are just disabling a bunch of features or a bunch of unsecure out of the box configurations, maybe is a better way to say it. So disabling the root login, disabling root SSH, um, which then, minimizes your attack surface a little bit to not allow for, if someone does get root access or elevated permissions on an endpoint, not allow them to then proliferate through the network via SSH and connect to other devices with those same permissions. As a not related to this threat, but as a general rule, you don't really even want to log in as root. You want to just sudo everything, run it as an administrative user, so you're not logged in as root and modifying things that don't need to be modified or leaving those permissions out there, right? And then again, disabling those outdated or vulnerable protocols. So for macOS, that was TFTP, which is trivial FTP, which is an unencrypted file sharing protocol. Limiting those SSH connections to have to utilize a FIPS compliant cipher. So making sure that your ciphers and your encryptions are at a level that is more difficult for an adversary to break or crack that encryption. And then the last one I wanted to hit on was just making sure that it applies some of those native security settings that's inside of macOS. I've learned over the last couple of weeks of trying to make, or the last few months trying to make macOS threats, that there's a lot of built-in features that make it very difficult to run programs and executables that they don't want you to run. The main one in the STIG and the CAT I STIGs for it was Gatekeeper. Um, so making sure that that is enabled, that that is applied, that that is running is also a very important check that it performs. If you guys were on our TT Live a few weeks ago, you saw us go ahead and deploy some Mac OS threats, and there is a lot of steps before you can get into that, and that's all because of Gatekeeper and some of the other built-in native security tools that Mac OS has. And then
Yeah,
lastly, oh, go ahead, Trey.
I was gonna say they're a really weird setup too because they have made it extremely difficult to do things like that, like initial execution and other tactics. But they've also made it really hard to get logs out of their hardware as well.
It's been like impossible. I've been banging my head on that for the last couple of weeks. There is like no native logging you can have sent over to the seam. You have to have some kind of EDR installed. It's been quite a headache to do that. So you don't get what great logs that you would expect to get in maybe a Linux or Windows system, but you also make it a lot harder to run things. A little, you know, this in one hand, this in the other. Um, And then over to the last one, over to Linux. So again, disabling those root logins, root SSH logins. You just don't want to have that. You don't want to allow that, right? It also is set to disable unattended or automatic logins via SSH. And that's kind of accompanied by the next one that I was going to talk about to make sure that you don't have any accounts that have blank, empty dictionary passwords or weak passwords set. So kind of using the both of those in a compounding fashion almost, just to make sure that you don't have accounts that don't require any authentication, that if an adversary got on your box, they could SSH across to a different device without having to have any kind of credentials or anything like that. So if you have blank passwords or unattended logins, those can be accessed by anyone that has access to the device, right? You don't need to know the password. You don't have to run anything. You don't have to dump anything. You just make the connection, and that's it. So going in and making sure that those are disabled. And the last one that I wanted to hit on for Linux was again those disabling that outdated or vulnerable protocols. So for Linux, they hit on things like Telnet, which is the old school version of SSH. Let's call it an unsecure, unencrypted version of SSH to connect to endpoints across your environment. Disabling X11 forwarding, which X11 forwarding would allow you to run a graphical application via SSH. So that way, it doesn't allow you to run any kind of graphical. You can't run anything with a GUI across SSH. You can't have a remote desktop stood up across SSH or anything like that. Was the last one that they had on Linux that I thought was really of value to it. And again, it might seem like some of these are maybe a little too simple in some of them, like disabling telnet. Everybody knows to disable telnet, but it does not. Even on these, on I think this STIG is based off of Ubuntu 20 or Ubuntu 22. Even with that version, it is enabled. It's on there. It's enabled. You can utilize it. So just making sure that you go in after you install it and make sure that out of the box it's not secure, and you need to apply some kind of controls to your endpoints to help shore up some of these kind of low hanging fruit vulnerabilities.
And there's a lot more to these too. That's just highlighting a few of the pieces and parts that are in here. A lot of the checks are stuff, again, like Tyler said, they sound very trivial, but it's still stuff that like we're running into in active engagements. We're still finding weak or no creds. We're finding default logins, access, like unrestricted access for PS remoting, or being able to pull in PS exec and utilize it across the environment. Like, there's just a lot of little stuff
Yeah,
that
I mean,
are
and
big problems.
yeah, and like the PS remoting one, like you had mentioned, to test if you have access to PS remoting, it's as simple as running the commandlet of test tac ws man, and then you give it the endpoint IP address or host name, and it'll tell you if you're able to connect to it via WinRM. So if you have it enabled or allow for a weak authentication to allow the connections to your endpoints, it's very easy to check if they're able to see it. You could do just a one-liner that looks at maybe like a get net neighbor or your ARP table or something like that, or your CAM table, something like that, and then take the output of that, run it in a variable for each of these in the list, test WSMan, and then attempt a connection right after that. And then you essentially are able to then attempt a PS remoting session to every device that is connected to that endpoint.
And these checks are actually pretty interesting under the hood. I know you just got a quick look at the scripts and the output of what's coming, but they're doing a whole bunch of different stuff. In reality, it's checking all kinds of different registry keys and values. It's looking through configuration files on the endpoint. It's validating ports and protocols that are active and open and listening, and just so much more. So for those of you that are here with Scythe, take a minute and go check those out. These threads are very helpful, and they're a great way to start your baselining. We see it all the time where people think, oh yeah, we've covered that, we're good, but something happens, somebody makes a change, maybe a gold image starts to drift, and all of a sudden you have things like clipboard redirection is not disabled for like RDP sessions, things like that, or just protocols pop up or tools get added that you're not aware of. And this is an easy way to kind of do a quick check of that kind of problems.
Yeah, and to what you said on the gold image drift, it was a saying I heard on an exercise a few years ago that there is nothing more permanent than a temporary firewall rule. And it's like users, if they have the ability to make changes and things like that, they're going to, because they're just trying to do their job, right? Security is sometimes seen as the enemy. So by kind of periodically running these checks, running these hygiene checks, these STIG checks, whatever you want to call them, you can really verify that your endpoints have the configurations that they're supposed to have, and that you're not vulnerable to some of these, low-hanging fruits.
Yeah. So that's actually pretty good timing for today. We're right under that 20-minute mark. I think it's probably the first time we've ever done it.
I think so.
Yeah, we just wanted to talk to you guys, show these off for a quick second because it is valuable. It's stuff people are starting to think about more. We wanted to kind of give you a sneak peek into some of the stuff we had already had made. And as features in Scythe grow, there's going to be a lot more into this whole health check and hygiene format, new features, new capabilities, and to really automate it and make it a lot easier for you guys to do these checks. Eventually it's going to get to that point where you don't even have to run a threat. You can just kick off and do your thing and get some results back and get it in a usable fashion, not just a you're good or no good.
Yeah, so all this will be under the umbrella of cyber fitness. So
Yep.
this is just the first iteration of these checks in improving overall security, not just what is being done by named threat actors, but what can you do in a more preventative way to try to disrupt some of these impacts on the endpoint, right?
Exactly. Well, with that, I think we are going to call it for this week's Threat Thursday. We will see you guys at the next one.
Thanks, everybody. See ya.
Thanks for joining.